Good morning, students. Today we'll start a new chapter. The name of the chapter is Gravitation. Who is the main hero of this chapter, do you think? Newton, right? But you will see many more heroes were there, not only Newton. In fact, Newton has told in his books that he could only see far because he was standing on the or maybe sitting on the shoulders of giants. Matlab before him, many great people had done some work. And because of those works, because he analyzed those works, he was able to discover the law of gravitation, which is famously called Newton's law of gravitation. Newton's name may come, but many other people have contributed behind the story. Clear or not clear? So let us discuss that story little bit. So stories will not come in exam, I know, but it's an interesting story. So long back, people realized that their lives are somehow affected by occurrence of certain planets. So if some planets come, life is good. If some planets come, wars will start. So the king, what he used to do, he made the smart people. He asked the smart people to tell them when will certain planets occur in the sky. So what these smart people started doing, they started making models of universe, models, and based on that models, they will predict which planet will come when. Understood? Now there were two schools of thought. There were two schools of thought. One school thought Earth is the center of the universe. Earth is at the center. This was given by somebody named Ptolemy, I think. Ptolemy. And if you ask them why, they will say, uh, who made us? God. If God made us, we are important. If we are important, we should be at the center. You understood their logic. We are made by God, so we should be at the center. Simple. So Earth is at the center of the universe. This is called geocentric model. Then there was another school who thought sun is at the center. This was done by, I think, Copernicus. Copernicus. And if you ask them why sun is at the center, their reason was if God made light and he wants to distribute light to people, where will he keep it? Center, so that everyone gets equal light. Otherwise, what kind of God it is if it is giving more light to me and less light to you? Yes or no? So that logic they had, and there used to be a lot of fighting. Then came someone called Tycho Brahe, and he said, "Stop fighting, ma. Let us not just discuss theoretically. Let us do. Let us observe the sky carefully. And remember, this is before Galileo, so no telescope and all those things till now. Only eyes. So he said, let us use our eyes and do proper observation of the sky. And then we will decide who is right, who is wrong. It may be obvious to you now that science is of course done by doing experiments. But that time it was one of the first person who told that you should bring experiments in science. Now though we all know without experiment science doesn't exist only. But during those days it was more philosophy. But Tycho Brahe said, let us not do that way. Let us bring facts, experimental facts into our understanding of nature. So Tycho Brahe, he said, let us do observation of the sky. Now, he made some observatories and all these things he made. A lot of instruments he used to measure the angle of the stars from the horizontal. So all that he did. And he collected data. He collected data for almost 30 years. Can you imagine? The only problem was he was not so good in maths. Not so good in maths. So like us only, yeah. No, some of you are good in maths. So though he collected the data, though he had numbers for different planets, he didn't know how to relate those numbers. For example, in school days, you must have heard people did experiment for reflection. So they got a data like this: angle of incidence, angle of reflection. That if this is 0, this is 0, this is 10 degree, this is 10 degree, this is 20 degree, this is 20 degree. This is also data. Now, a mathematician should be able to look at the data and make a law, make a relation between the variables. So, tell me what relation will you make from this data? Suppose you were the scientist. I equals to R. So, that was easy, no? But here the problem was too much complicated data. Analyzing the data was very not easy. And he was not so good in maths also. So he hired one smart guy who was very good in maths, and his name was Johannes Kepler. Johannes Kepler. Now there is a little bit of myth in this story. Myth matlab something which is not actually true, and that is Tycho Brahe gave Kepler some data to analyze, but some he kept with him. Brahe never gave the whole data. Okay, he gave probably for Mars. For Mars planet, whatever data he collected, that he shared with Kepler. And Mars data was very complicated. I'll tell you why. If ever you observe Mars, okay, in the night sky, for long duration you have to observe, then you will see that it will move this way, and then somewhere it will come back and then again go forward. This coming back part is called retrograde motion. What motion? Retrograde. Coming back part. Coming back. Now that coming back part was against this model. Because if Earth is center, everything is revolving around Earth. Then how did this Mars went like this and like this? The back motion, how it happened? That back motion could be actually explained by this model. Okay, that I will let you know one day. Matlab, maybe now only I'll try. Let's say I am Earth. This is Mars. According to this model, Mars should go around me. So I will always see Mars moving in a particular direction, in one sense. I will never see it coming back once like this. But in this model, what happens? Sun is the center. I am Earth. I am also revolving around Sun. Mars is also. So now Mars is that side, I am this side. And whoever is nearer moves faster, remember. That we will discuss later. Because of more force, there will be more centripetal force. So you can move with more speed. That we will see later, don't worry, when we discuss the theory part, the mathematics part. But I am Earth, you are Mars. So right now you are ahead of me. But because I move faster, I will see you going back. In my frame, I will not see myself moving. No, it's like in car. If you are behind, suppose you are driving and one car is in front of you. If you are moving faster, what do you see? You see that car coming back and then go forward. First you will see it coming back. Why did you see it coming back? Because you are moving faster. After that, you will see it going in one direction only. So that a particular observation led to this idea that maybe this is wrong. And one more thing about Brahe was he used to do observations at night. So full busy at night. Daytime, full party. Party person he was. Not he would not no stay calmly at home. He will call his friends and all these people will come. Full music and drinks and all they will enjoy. Full masti. Now what happened in during one of the parties, they were having food, okay, and he must have drank too much, so he wanted to go to washroom. But during those days, while eating with a group, you can't simply stand and go. You understood? Today now also it is not considered very polite. So he was waiting when other people will finish, but they were eating very slowly. Understood or not? And this led to some infection in his bladder because he stopped going to washroom for a long time just because of politeness. This part is true actually, and he died actually out of that bladder infection. Once he died, later some people had suspicion, did he really die because of infection in the bladder or someone may have poisoned him. So what they did, they took his body out from the grave, okay, and analyzed his nails and hair. Nails, why do people analyze? Do you know? Nails are like trees. The deeper you go, you will come to know the history of the tree. When a tree grows, first it will be thin, then new layers will come. So as you go inside the layers of that tree, you will come to know its history. So they analyzed the layers of the nails and found that there was mercury content, mercury, and it was quite high during that. The first they did it two times. So first time when they took out from the graveyard and analyzed, they found there was a good amount of mercury content, and therefore it was told that maybe he was poisoned. And the doubt went to whom? Kepler, because Kepler was asking for data. And there is a false story actually that his family, Brahe's family, accused Kepler that he must have done that. Go to his house, you will find data, because we don't see the book in our house. So when the officials went to Kepler's house, they actually found the data. Understood? But now, recently in 2010, again they took him out, and then when they analyzed, and this time the science is more advanced, they found it is actually false. That much mercury was supposed to be there during those days, because during those days all these medicines and all whatever they take for any problem had mercury content, had mercury. So it was not Kepler. But there was a doubt that Kepler may have done. But who knows? We don't know the history. Kepler may have done, may not have done. But the good thing is he took the data. That is the good thing. Now whether he stole it or he just took it, that I don't know. But he took the data, and from that data Kepler made his three laws, and that is the starting of our chapter. Clear or not clear? So Kepler's laws is the starting of this chapter, and that led to Newton. These laws made Newton discover his law of gravitation. Kepler's first law is called law of orbits. Law of orbits. So law of orbits. This is the only law which we will not prove in our class. We will just accept. Other two laws we can prove. This one we will not prove. Okay, we cannot actually do it because the mathematics required is little bit advanced for class 12. So what is this law of orbits? Write down. It says every planet revolves around the sun in elliptical orbits with sun at one of the foci. With sun at one of the foci. Foci spelling you know. Elliptical orbit first you know. How does ellipse look like? Flattened circle, right? You take a circle, you push it this side. So what happens is you have a circle. Circle has just one center. Now you push it, it becomes an what? Ellipse. And it's like the center will split like this. And those two, we don't say center, those 2 points are called foci. How to draw this actually? Perfectly how to draw? How to draw perfectly a circle? Do you know? Put one pin here, put one pin, nicely, fixed it. First take a cardboard, then put a paper, then put a pin. Now you take a thread. This is the pin, let's say this is the cardboard. Put a thread like this and here put your pencil and take the pencil as far as you can. Then this thread will become tight or not. Now keeping this fixed, move like this. Yes or no? So you will get collection of all those points which are at same distance from this fixed point. That collection of point is what is called circle. Similarly, how to draw ellipse? Try at home and share video to me. Okay. So what you do, take cardboard, put paper, take 2 pins, fixed one here, fixed one somewhere here. Where sir exactly doesn't matter, wherever you put. Again take the same thread, put the thread like this and put your pencil here and push it as far as you can go. Of course don't push it so much that the pins come out. Understood? So probably you will get something like this. Let me try to show you the thread. So here your pencil will be there. Now you go like this. So you will trace out a nice what? Ellipse. And those 2 points will be the focus. Here what was constant? This was constant. If I say AB, then AB was constant. That's the definition of circle. Here what will be constant? This will be constant. No, because as you go to different points, this will increase, but this will decrease. That means this is not constant, but this plus this, that is constant. Agree or disagree? That means for ellipse, if the planet is revolving in this orbit, this distance plus this distance, F1P plus PF2 must always be constant. That's the definition of ellipse. Then we have 2 terminologies which you should know. The largest distance between 2 points in the ellipse is called major axis, major, and half of this is called semi-major axis, semi-major axis. And the shortest distance between 2 points on the ellipse is called minor axis, and half of this is called semi minor axis. Major and minor in what else have you heard? Music you may have heard, right? Major, minor. P is what? Yeah, but who is that P? Planet. And sun will be in one of the focus, one of the foci. The next one, the second law. There are 3 laws. The second law of Kepler is called Law of areas. Law of areas. So what this law says, let us try to understand now. First you try to understand, then you write. So as I told you, according to first law, our planets, including Earth, moves in a elliptical orbit, not circular orbit. But for later, after we complete Kepler's laws, all our problems, most of the problems will be assuming circular orbit. So right now, let's say Sun is here and our planet is here. Now listen carefully. Let's draw a line joining the Sun and the planet. This is the line joining the Sun and the planet. As you wait, this planet is moving. Correct? So when the planet is here, let's say after, I don't know, 2 months, suppose the planet is here. Then this line, sir, in 2 months it will move only this much. It's a big orbit, no. It's not like racing track that in 2 months it will move this much only. This is planets we are talking. Our Earth will come back here in 365 days, 12 months. Understood? So in 2-3 months it may be somewhere here. So this line will reach here. So what this line did, it swept some area, sweeping, jhadu marna, jhadu. Mothers will tell, no, hey, sweep the floor like that. So this line will sweep some area. This is the area swept by the line joining the Sun and the planet. According to second law, from here to here, if we took time, let's say delta t. Here time is t, here time is t plus delta t. Then what is the time taken? Delta t. And let's say this area covered is delta A. Then according to this law, delta A by delta t remains constant. And if you take limit delta t tends to 0, then what will this become? Who remembers? dA by dt. Calculus. Delta y by delta x when delta x tends to 0 is dy by dx. So this will be dA by dt. If there was here x, position of a particle moving in a straight line. If there was x, what do we call dx by dt? Velocity. This is but area, not x. So we call this aerial velocity. What velocity? Aerial velocity. So what the law says in very short words, few words. What does it say? Aerial velocity of a planet is constant. Matlab it covers equal areas in equal intervals of time. When your velocity is constant, what does it mean? You cover equal displacements in equal intervals of time. But this is displacement or area covered? Area covered. So it covers equal areas in equal intervals of time. Meaning, in delta t time, this much area was covered. If you wait again for delta t, you will cover same area. That is the meaning of this law. That means when our planet is somewhere here, after some time it will come here. This is the line joining Sun and planet. If you again wait for delta t, let's say here you waited for 3 months, here also you wait for 3 months. Then what do you think? Here it covered this much distance. Do you think here it will cover same distance or it has to cover more distance? It has to cover more distance because area has to be same. They did not say distance is same. When did I say velocity of planet is constant? I mean, when did Kepler's second law said velocity is constant? It says who is constant? Aerial velocity. Aerial velocity matlab it covers equal areas in equal intervals of time. So therefore, if it covers this much area, here also it should cover same area. But can you see this distance is shorter than this distance? That means here it should cover more. If you take triangles, if you take this side more, but you want same area, then this side must be small, no? Half into base into height. So if one triangle has more base, that triangle should have less height, then only area will be same. Alright? If this is 5, this is how 5 it is? 4. Then if this becomes 10, this must become 2. Then only area will be same. Half into 5 into 4, half into 10 into 2, same. 5 4s are 20, 10 2s are 20. That means here since this side is less than this side, here this side must be more. So in the same interval of time when the planet is here, it must cover more distance. But you said it should be same. Area should be same, I told, not distance. That means according to second law, it gave you a new idea now. Which new idea, sir? Where the planet has to move faster? When it is far from the sun or near the sun? How? Because it has to cover more distance than here. So that this law gave us another idea that when planets are near the sun, it has to move faster. And that gave Newton idea that there must be some more force also. And that gave Newton that inverse square law. If distance is less, force will be more. All that idea of Newton came from here. Understood? So if this area is delta A dash in time delta t, then according to this law, delta A dash must be same as delta A. Areas must be same if time taken are same. Put in words now. It says the line joining the sun to the planet sweeps equal areas in equal intervals of time. So the last law of Kepler is called the law of periods. Law of periods. When does the word period come? When it repeats, when things repeat, or when it never repeats? When it repeats, and our planets are going to repeat the motion. Yes or no? So what is the meaning of period here? Time taken to complete one revolution. Starting from same point, you have to come back to that point itself. So what this law of period says, well, this is where the data was very useful for Kepler. And for many planets, that time all the planets were not discovered, by the way. All the planets were not yet discovered. But whichever planets they knew, they measured the distance of that planet from the sun. The semi-major, or no, it is not. Yeah. So, yeah, you can measure the distance of the planet from the sun, not a problem. And using that, you can find the size of the orbit. And by size of the orbit, I just mean this, half of this. Okay. Till now, whatever laws we studied were specific to individual planets. But the third law will compare one planet with another planet. In what way? Listen carefully. Suppose you have two different planets with two different orbits. This A will be same or different? Different. Here if the time period to come back to the same place is T, here it will be same or different? He found it is different from observations. So for different planets, he wrote the half of major axis for different planets, planet 1, planet 2, planet 3. So some numbers were there, and he also measured the time taken to come back to the same place. So some numbers were there. Then he found, Kepler, through the data, that if you cube this one and square this one, you will get some numbers, isn't it? And when this number changes, obviously this number will change. But whenever you take the ratio of these two numbers, a cube by t square or t square by a cube, this was found to be constant no matter which planet you choose. In other words, he found that the law of periods. So from this data, Kepler found the third law, which says square of the time period divided by cube of the semi-major axis remains constant for all planets. If you cross multiply, what I can write? T square is proportional to a cube, right? Which also means for two different planets, T1 square by T2 square will be equals to A1 cube by A2 cube. Or you can write T1 by T2 whole square is equals to A1 by A2 whole cube. Because it's proportional. So when you take ratio, constant will cancel. This constant will cancel, no, for two different planets. So T1 square will be equal to constant A1 cube. T2 square will be what? Constant A2 cube. Divide those two. Constant will cancel, you will get this. So this formula is very useful because Earth's radius we know, orbit's radius. And if you know another planet's radius, orbit's radius, in terms of Earth's orbit's radius, if you know these two, then you can easily find time period of the other planet, because our Earth's time period we know 365 days. So this formula is very useful to find time period of another planet in terms of time period of Earth. Okay, now we will quickly try to understand the proof of second law. What was second law again? Does anyone remember? Now you will see that that law happens because of law of conservation of angular momentum. Do you remember law of conservation of angular momentum? For angular momentum to be conserved, what should be zero? Torque about that point should be zero. Force, why it should be zero? Torque should be zero. Force zero means momentum should be conserved. So force zero means momentum is conserved, torque zero means angular momentum is conserved. So now second law is true because of law of conservation of angular momentum. And why is angular momentum conserved? Because the force acting on the planet by the sun is actually a central force. Central force means what, sir? Central force means if he is a sphere, I am a sphere, the force between us will be along the line joining the centers. If he is a sphere, I am a sphere, central force means our force will be along the line. Our force means force on me by him. And Newton's third law says if I feel force because of him, he will also feel force because of me. That force will be along the line joining the centers. Let us try to see how second law will come now. So I will now try to prove Kepler's second law. Cross product, do you remember? What is A bar cross B bar magnitude? Everyone tell fast. AB, what theta? cos theta. Then what is A bar dot B bar? AB don't know theta. A cross B magnitude is AB sin theta. Now try to understand what this is. Look here. Suppose this is a vector A bar, this is a vector B bar. If I draw a line here like this, the area of this triangle that you see is actually half of this. The area that you see here is half of this. How, sir? Try to understand. Let me make this little longer for easy to understand. So if somebody says what is the area of this triangle, what will you do? First you will draw for a triangle, what you should first find to find area? Height. So from here you will drop a perpendicular. Let us call this H. What is theta in this product? Theta is what in this formula? Angle. Angle between what? Elephant and A bar and B bar. So theta is angle between A bar and B bar. That means this is theta. Now tell me what is H in terms of theta and this side. What is the length of this side? Length B. So if I write sin theta, what will you get? Opposite by hypotenuse. So what is height? B sin theta. So what is area of this? Acha. You should not get confused with this A bar and this A now. This is area. Let me write full spelling only. So what is this area if I ask? This area. Half into base. If you choose this as height, this will be base. If you choose this as height, this would be base. But I have chosen this as height, then this will be base. So base into height. What is height? I already found. B sin theta. Oh, acha. And who is this brother? Modulus of A bar cross B bar. So if somebody says there are two vectors, what is area formed by these two vectors and this side? Then it is half of cross product. Half of cross product. So that way if you do, things will come very nicely here. So look carefully. This is your elliptical path in which the planet is moving. Here is sun at the focus. This is your R vector from the sun. I'll choose sun as the origin. So this is your position vector of the planet. Velocity is always along the tangent. So in time dt, this will go somewhere here. This line will go somewhere here. So this vector will be what vector? V bar dt. So what will be this area if I ask you? Then the area here will be half into cross product of this with this from that knowledge. So it will be R bar cross V bar dt. So what will be aerial velocity? dA by dt is equals to half R bar cross V bar. Magnitude I forgot to put because this is just magnitude of area. Now let me multiply with mass and divide by mass. Since mass is scalar, I can put it anywhere I want. I will put it here. So I have to divide by mass also. This part from here to here, is it clear? First you tell me from here to here is clear or not. dt I brought it here. Then I want to bring momentum. So I multiplied with mass, I divide by mass. Mass is a scalar, I can put it anywhere I want. I will put it here. Then this will become momentum. What is R bar cross P bar? R bar cross P bar, L bar. So this is L bar magnitude. So what is aerial velocity equals to if I ask? L by 2m. And no matter where is the planet, the force on the planet by the sun will always pass through the sun, because this force is a central force. What force? Central force. So if the force is passing through sun, torque about sun will be 0. If torque about sun is 0, from conservation of angular momentum, L about sun will be what? If torque is 0, L about sun will be what? Constant. If L is constant, this is also constant. And that is the proof of Kepler's second. Newton's law of gravitation. Statement you write first. It says the gravitational force between two particles is directly proportional to the product of the masses and inversely proportional to the square of the distance between the particles, and the force acts along the line joining the particles. So my doubt is, how did Newton came to know it should be r square? Did they do meeting and decided? A majority, if they say r square, we will take r square. Like they did, or experimentation? Some kind of measurement they must have done. Laws comes through measurements, not through voting. Understood? Science is not politics. So how did he know r square is there, not r cube or only r? Why r square only? Why? That you can understand in a simple way from Kepler's third law. Kepler's third law says what? T square is proportional to distance cube, a cube. Let us assume circular orbit for the time being. So T square is proportional to r cube. R represents distance between sun and the planet. Let us assume that. So for circular orbit, there is no focus and all. Sun is here, planet is here. So your A will become simply R. Yes or no? Now, we know from kinematics of circular motion that the acceleration of this planet is given by what in circular motion? V square by R, because it is moving in uniform circular motion for circular orbit. For elliptical orbit, it is not uniform. For elliptical, when it is nearer the sun, faster it moves. Farther the sun, slower it moves. But in circular orbit, it is at same distance, so it will move with what speed? Same speed. And when you move with same speed, if your speed is constant, then there cannot be any tangential acceleration. There has to be only centripetal acceleration. So what is the acceleration centripetal for the planet? V square by R. And force from Newton's law is m into AC. So centripetal force will be what? mv square by R. Now, this speed of the planet around the sun is also this total distance covered by total time taken, because I need to bring time period. Can you tell me what is the distance covered in one time period? 2 pi r divided by t. Put this speed here. So what will be your F? M by R into, what will be V square? 4 pi square r square by t square. Here t square is proportional to r cube. That means t square is equals to some constant r cube. Substitute that t square here. M 4 pi r 4 pi square r square divided by small r t square is proportional to r cube. So t square is equal to some constant r cube. Check what is this. Forget the constants. Tell me about r. Some constant divided by r square. Now you understood how force has r square in denominator. It comes from Kepler's third law. Another way is there to understand, and that I will give you as a homework, the calculation part. But everyone has to do. Those who are in hostel should take help from Sandhya ma'am or Mahadev sir, because you will need some values from our google.com. So what you have to do is, this is earth, right? This is earth. Let us consider an apple very close to earth. Consider an apple very, very close to earth. Let it go. It will fall down. With what acceleration does it fall? So acceleration for apple will be equals to 9.8. How far is the apple from earth's center? R1. Let's say R1 is what? Radius of earth. Radius of earth, so I also remember 6,400 kilometer. 6,400 kilometer. This was done by Eratosthenes long back using protractor. You can see that video in my channel. Only using protractor he found what? Radius of earth. So this was known to people at that time. Then for moon, now just like apple is falling, so moon is falling or not falling? Not falling. Then what happened to the force then? Earth is attracting only apple or moon also? Huh? Heaven's laws are different, huh? Heaven's laws, earth's laws, all are same. That's the beauty of Newton's discovery. Before, people used to think in heaven laws are different, because there who stay? Gods. Here who stay? You and me, mortals. They're immortals. But Newton said, doesn't matter whether it is God, whether it is heaven or earth, laws of physics are same. So my question to all of you is, moon is falling or not falling? Huh? Not falling, then what happened to this force? Then what happened to this force which earth applies on moon? Moon's force will not act on moon, ma. Moon's force will act on others. Very sad, students. Moon is actually falling. Moon is actually falling, but it is falling from this straight line. It is falling like this. Do you know that moon is orbiting earth? Yes, sir. Yes. So moon is also revolving around earth. So it is falling from this straight line. If this force was not there, what would have happened to moon? Newton's first law, what it said? Forgot. A body in motion continues in the same motion if there is no external force. So if this force was not there, after some time, moon will bye-bye. Never, tomorrow night you will see, array, where is moon? Gone. So because it is moving and there is a force, this force makes the moon fall from this straight line. Then when it reaches here, it will fall from this straight line. Will reach here, it will fall from straight line, from this straight line. When you fall, if you run from a, let's say some building, and you jump, how do you fall? Like this. You go like this, no. That is also fall, no. Then why this is not fall? But luckily moon is falling from such a good height that it misses the earth's surface. The curvature of this and curvature of earth will exactly match, and therefore we don't have to be scared of moon hitting us one day. Okay, so this became dirty now. These two data was for whom? These two numbers were for which body? This acceleration was whose acceleration? Apple. Now you are telling earth. This is Apple's acceleration, this is Apple's distance. From where? Center. Now moon's distance from the center is, let us say, R2. That R2 you have to collect from internet. That is your homework. And moon's acceleration also, it is not so difficult to calculate moon's acceleration. It's not so difficult because moon is going in circle around the earth. So for moon's acceleration, that also you try to find, but let me tell you what formula you can use. You can use v square by r. V can be written 2 pi r by t by r. Because in one circle you will cover what distance? 2 pi r. So what will be speed? Distance by time period. So this will give you 4 pi square, 1 r will cancel by t square. So how far is the distance of the moon from the earth's center? That you will find, I told. Put that r here, and time period of moon is how much approximately? I think 27 days something. So that you check, substitute and calculate, or directly ask what is the acceleration of moon in its orbit. Now these two numbers you have to collect. Tomorrow I will see 100%. Then you have to check what is the relation between, then you have to check A1 by A2. You have to divide. Who is A1? Acceleration of Apple. What is A2? Acceleration of moon. Then you repeat this for, then you do for R1 by R2. And you will see that A1 by A2 will be equals to R2 by R1. Better to check R2 by R1 whole square. This you have to prove. Matlab this number which will come here will be equal to square of this number. This proves what? What this proves? If y is inversely proportional to x, what will be y1 by y2? All of you keep quiet. Rohit, stand up. What will be y1 by y2? X? Why x2 you kept in numerator? Inversely. Sit down. Suppose there was a square. Then what will happen in the ratio? Whole square I have to put. Because y1 will be some constant 1 by x1 square. Y2 will be some constant 1 by x2 square. When you divide, constant will cancel, x2 square will go up. Can't you see these two are same? So what does this prove? Acceleration is inversely proportional to distance square. And you know from Newton's law, force is proportional to acceleration. So this is how you can, this is how Newton found. Because these data were known during those days. So how will you write Newton's law of gravitation mathematically? Newton's law of gravitation, mathematically how will you write? First you have to choose two particles. First you have to choose two particles. Understand, Newton's laws are only valid for particles. But sir, you applied for earth also. Yeah, that is interesting question. Well, after some time I will show you that luckily for earth, Newton's law still works the same way that he gave. the formula that he gave for particles will also work for Earth, provided you measure the distance of Earth from the apple or distance of Earth from the moon from center to center. From center if you measure, you can use the same formula. But why it is like that, that we will discuss little bit later. But Newton's law of gravitation, the formula that we write, is only valid for particles. For big bodies, we need to do some changes. Luckily for spheres also it will work. For spheres also this formula that I will write now will work. But you have to measure the distance from center to center. Then it will work. That too, one of the sphere should be outside the other sphere. If it is inside, for example, I can always take apple inside Earth. I can always put apple inside Earth. What is there? You can make a mine. There are already mines actually. Why to make? Just take apple inside the mine. Deep mines are there. There, the formula for force on apple by Earth will be not same as this. So we need to see why that happened. So first understand the way that we are going to write Newton's law of gravitation now is only true for particles. So if you have two particles with mass m1, m2, distance between them r, then Newton's law says the force between them, magnitude, is what he told. What Newton said, the force is what? Directly proportional to product of the masses, and inversely means where I should write? Inversely proportional to square of the distance. So this is the statement of Newton's law in mathematics. If you put equal to, what will come? Some constant will come. We have discussed long back when we studied proportionality. That constant we write as capital G. In units and measurement, we actually found the units and dimensions of capital G. I hope you remember. In the topic units and measurement, we found the dimensions and unit of capital G. So capital G is a constant. It is called gravitational constant. It is universal. Universal in the sense it's true everywhere and it's true every time. The value of this capital G will not depend on anything. Tomorrow you put water in the middle and ask what is the force between these two. It is this only. The water will obviously change the net force. The force on me by earth, that force will not change even if there is water in the middle. You understood what I am saying? If, see here, this is body, earth is there. There is a force on this body by earth. Now let me put water, let me put this body in water at same distance. The force on this body by earth is still same. But net force will change because water will also apply some force. So total force will 100% change. But the force of gravity between chalk and earth, that will remain same, which we used to write mg. So this is the Newton's law of gravitation, which gives force between the particles, and capital G is called gravitational constant. Can you quickly tell me the SI unit? For that, what will you do? Bring capital G on the left side. Then if you cross multiply, you will get Fr square by m1 m2, isn't it? Cross multiply here m1 m2. So what will be unit? Newton meter square per kg square. Dimensions you can do yourself. And where the force will act? Along the line joining the particles. Attractive or repulsive? Gravity is only attractive. Now tomorrow suppose I give you one star shaped body and one cat shaped body. This also has mass m1, this also has mass m2. So Newton Baba said they should attract each other. Yes, there is attraction between them actually. And if they ask you to calculate the attraction, calculate the force, you cannot use this formula. Why, sir? M1 is there, M2 is there. Okay, M1 is there, M2 is R. What will you do? R. From where? From here to tail you will measure. From stomach to stomach. So this R is not defined if the bodies are asymmetrical. If it is round shape, luckily you can choose center to center. Otherwise, R is not defined. Then how to do? This is where, this is why Newton discovered integration. That's why Newton was so great. Normally what physics people do? They do some problem, they analyze nature and they see, oh, to do this, I don't have the maths only. So they go to mathematics department. They say, hey people, did you do any maths about this? They say, no, no, we have not done. Like Einstein wanted to study curved space in his theory of, general theory of relativity. He wanted to learn about curved space. But Euclidean geometry that you study in school is about flat space. In flat space, what happens? The sum of interior angles of a triangle is 180. But in curved space, it is not 180. Try at home. Try to draw triangle on a globe. It will look like this. There, if you include the interior angles and add, you will not get 180. In flat space, if two lines are parallel, they will stay parallel. In curved space, if you start parallel, they will meet at the poles. So the geometries are different. So Einstein wanted curved space geometry. Luckily, one mathematician had done it already. His name was Riemann. Riemann geometry. So Einstein used it. So physics people do like this normally. But see the greatness of our Newton Baba. Nobody did the mathematics. He himself did the mathematics. Differentiation and integration. So what is the idea? If somebody will say find force between them, these two, what will you do? Divide this into small pieces. Divide this into small. I mean, don't cut this one, ma. In imagination, we are telling. In imagination, think this is made up of small pieces. Now take one piece and one piece. Force between those two pieces. You can use this formula. So find force on this piece by this piece. dF. That's not the story. Now find force on again that piece by another piece. Find force on that piece by another piece. Force on this piece by another piece. So find force on this piece by all the pieces using integration. Then go for second piece. Then find force on second piece by all the pieces. Then add all the forces on the pieces of the cat. That will be total force on the cat by the star. That way. Matlab, we can still use these, but we have to do integration. Artha aita? Okay. Directly don't apply. So that's why this formula holds only for particles. Luckily for spheres, if you do what I told, the answer comes in such a way that everything will be same except for spheres. This R should be taken from here to here. So this is the result Newton discovered through integrations. So one simple question for all of you. Force between two particles is F. If masses of each particle is doubled and distance is halved, what is the new force? Force between two particles is F. Which force we are talking about? Which force we are talking about? Now what they did, particles mass is doubled and distance is halved. What will be new force? Who can do directly? Masses are in numerator. So if each mass is doubled, 2 will bring 4 in the numerator. R is square is in denominator, R is halved. So half square will be what? 1 by 4, that 4 will also go up. Already 1 4 is sitting, so force will increase 16 times. Didn't understand, huh? Those who are not understanding, see here. What will be new force? G. G will be constant, I told. What is the mass now? 2m1, 2m2. Why 2m1, 2m2? Masses are doubled. Distance is what they told, half. So before what we used to write, r square. Now what I will write? R by 2 square. This will be what? 16 g m1 m2 by r square. How 16 came? Are 2 square 4, 4 will go up. Already 2 and 2 are sitting in the numerator. What is this now? This is the original force. So force increases how many times? 16 times. If force increases 16 times, what will be percentage increase if they ask? Percentage increase, how will you calculate? New force minus old force divided by old force into 100, which is 1500%. Oh my God. Let us write now Newton's law of gravitation in vector form. In what form? Vector form. I'll keep one particle at origin and another particle I'll keep somewhere here. Then the position vector will be this or not? This is r bar, let's say. What this r bar will give? Position of second particle from first particle. Now if r bar is here, r cap will be also there. And how will you write r cap? R bar by mod of r bar, which is r bar by r. I hope unit vectors and all you are very comfortable. A cap is a bar by mod of a bar. So r cap is what? R vector by mod of r vector. Mod of r vector matlab this distance. Now force on m2 by m1 is attractive. So if I show the forces separately, force on 2 by 1 will be this side. This is force on 2 by 1 and this will be force on 1 by 2. How to write this force in vector form? Okay, vector form. So F21 vector, how will you write? Mod into unit vector. Now which unit vector is in this direction? Check this diagram. R cap I have shown this way or this way. If you have shown R bar here, R cap will be here only. R bar is always chosen away from origin. That is the convention. So if R cap if I choose here, then R cap is in this direction? Yes or no? Is R cap in the same direction as this? No, this is where? Opposite. That means I should write what here? R cap or minus R cap? Minus R cap. This formula you all know. Any vector is written as magnitude times unit vector. Any vector is written as magnitude times unit vector in that direction. So unit vector in this direction is not r cap, it is minus r cap. Magnitude you already know, g m1 m2 by distance between them. Distance between them means r cap with a minus sign. So this is called vector form. What form? Vector form. You can substitute this r cap here, then it will become minus g m1 m2 r bar by r cube. How r cube came? This r cap I substituted here. And what will be F12 vector? This vector. This is force on M2 by M1. This is force on M1 by M2. How will you write this force? The way you wrote this force, how will you write this force? Magnitude times unit vector. Which unit vector is in this direction? R cap. So I will not put minus this time. And magnitude is given by Newton's law of gravitation. What was the Newton's law? G m1 m2 by r square r cap. If you analyze these two, what did you say? F21 vector is, if you analyze these two, what do you say? F21 vector is what? Minus F12 vector, which is Newton's third law. Obviously, Newton's laws among each other should agree, no? Why will I make a law which will disagree with my other law? So I hope vector form is not so complicated, students. Just put one particle at origin, one particle wherever you want. Draw the vector showing the position of this particle from this particle. Then show the forces. Normally they draw in the same diagram, but you may get confused regarding the arrows. So I just separated the force diagram and position vector diagram. Then you can see this vector of force is opposite to r cap. That's why I put minus r cap. And this though you already know that any vector a bar is mod of a bar times unit vector in the direction of a bar. This you remember, no, from vector? Yes or no? Thank you.